Good morning, this is your Stats Sensei, Mr. Spensei, and this is classwork 3A.5, which is Venn diagrams and classical probability. So police report that 78% of drivers stopped on suspicion of drunk driving are given a breath test. So 78% are given a breath test, 36% are given a blood test, and 22% are given both. As I said before, if they give you both, that's where you want to start. So that doesn't require any work, so we can sit there and write down both. And by the way, I'm going to write down 78%. So this is 0.78. Blood test, 0.36. And both is 0.22. Okay, I'm going to go ahead and record that into the Venn diagram, the 0.22. And we're going to note that both is highlighted and it doesn't require any work. We can just copy it just the way it is. Oh, look at that. Isn't that pretty? All right, so we have 22. Now, to do the breath, I can't just write 48. I have to actually do some subtraction because this part right here includes, this whole circle is 78. But breath only is going to be 0.48 minus 0.2 or 0.78 minus 0.22. And let's go ahead and do that real quickly. So 0.78 minus 0.22 is 0.56. So breath only is 0.56. Blood only, we're going to have to take the blood and subtract the both. So 0.36 minus 0.22. In that case, we're going to get 0.14. Let's make that blue. 0.14. So blood only is 0.14. Both is 0.22. And breath is 0.56. We still have this area out here where we have neither. To find neither, we're going to add up these values and subtract from 1. So 1 minus 0.56 plus 0.22 plus 0.14. 1 minus parenthesis 0.56 plus 0.22 plus 0.14. And that tells me that this area out here is 0.08, and this is a neither. And I'm going to go back and redo this real quickly. If I add up these values right here, the 0.56 plus the 0.22 plus the 0.14, I'm going to get 0.92. So this ends up being 1 minus 0.92. And that equals the 0.08, which is our neither. Okay? So what's the probability a randomly selected DWI suspect is given a test? Well, I'm going to flip over back to the pretty notes real quickly. And given a test, that means they could be given the breath test, they could be given the blood test, or they could be given both tests. That's where you need to rely on this formula. Once again, we will give you this formula, but you have to know how to use it. A union B equals the probability of A plus the probability of B minus the probability of A and B. And you're like, well, how do I know to use that? That's a great question. And the reason you know to use it is because we can be given a breath test or a blood test or both. And when I use the word both, that means add, and union, the union sign is, or the U sign is for add and or. So that tells me that, oh, I have to do this or this or this, so I'm going to have to use this formula. Now, we have breath and blood, so we're going to use BR and BL. So BR for breath, union blood, equals the probability of breath plus the probability of blood minus the intersection. And that's what we have there. Okay? Well, what is the probability of breath? 78%. Probability of blood, 36. And the probability of both is 22, and we subtract that out and we get 0.92. What is the probability that a driver is given a blood test or a breath test, but not both? Well, there's a couple ways to look at that. First off, we're looking at a blood test. That's the first thing they asked for. So blood test is right here, but we didn't want both. So the probability of a blood test, but not both, is 0.14. And the probability of a breath test, but not both, is 0.56. I keep picking up the wrong marker. Okay. So when we add those up, the probability of having either the breath test or the blood test, but not both, is 0.56 for the breath plus 0.14 for the blood. What's the probability a driver is given neither test? Well, we did that already. Neither's out here, but what we did is we added up this plus this plus this and subtracted from 1. That 0.92. So we basically said, and you're probably wondering where that came from, that 0.92, we went 1 minus 0.56 plus 0.22 plus 0.14. And that gives us 1 minus 0.92, which equals the 0.08. What's the probability selected driver is given a blood test, but not a breath test? Okay. Selected driver is given a blood test, but not a breath test. Well, what's the probability of a blood test? The blood test only is this section right here, so that's 0.14. What's the probability a driver is given a breath test? A driver is given a breath test. What's the probability the driver is also given a blood test? Well, guess what? Given, all right, a driver, and so this was their probability of one and the other. So since it's one and the other, we know it's going to be intersection over given. What were we given? We were given a breath test. What's the probability of a breath test? We have to look at the total probability of a breath test, and the total probability of a breath test is 0.78. And the probability of both is 0.22. So we end up with 0.22 over 0.78 because the probability of both, the intersection over the given. Next, what's the probability a driver had a breath test but not a blood test? Okay, had a breath test but not a blood test. That means I'm only looking at breath. And if I'm only looking at breath but not blood, that means I can't have the both, which means I'm only looking for that 0.56. What's the probability a driver who has taken a blood test will also be administered a breath test? Okay, so this is again intersection over given. Given that they've had a blood test, what's the probability of a blood test? Probability of a blood test is 0.36. So we're going to have 0.36 in the denominator, and then we're going to have 0.22 on top of that because it's intersection. And remember, intersection represents the overlap. Okay, and don't forget, this is an intersection over given. And what were we given? We were given they had a blood test. We want to know both, which is the overlap. Are taking a blood test and a breath test disjoint? Disjoint is another way to say mutually exclusive. To be mutually exclusive, our Venn diagram has to look like this. Absolutely no overlap. I see an overlap of 0.22. So guess what? It's not mutually exclusive. Since the Venn diagram overlaps, a driver can be given both, and the probability of that is 0.22. It is not a disjoint event. The probability has to be zero where there's no overlap. Here it has to look like this. No overlap is zero probability, but here we have a 0.22 probability of both, so not going to happen. Are taking a blood test and a breath test independent events? Okay, to be independent events, we have to use this formula. The probability of A and B equals the probability of A times the probability of B. A and B, that's the intersection equals the probability of A times the probability of B. So this is the both. So in this case, the probability of breath and blood equals the probability of breath times the probability of blood. So when we do that, the probability of both is 0.22. And let's take that 0.78 times the 0.36, the probability of blood, and it's 0.2808. The overlap does not equal that. So it's not independent because this is not a true statement. Okay, the last thing it asks us to do is create a contingency table for the above. So let's look back at our problem. Well, first off, what was the probability? 78% are given a breath test. So 78%. That tells me right here, my breath is going to be 0.78. And by the way, I could go ahead and skip ahead and do the easiest part. The easiest part is going to be 1.0. This will always be 1.0 if we're working with probability. Now, the next thing it asked for that they give us is they said, well, what 36% are given a blood test. Well, 36% blood test, that tells me blood is right here. This is 0.36. The next thing we know is the both. The both is right here at 0.22. Let's go ahead and mark that in. At this point, we can fill in the entire table just by using math because everything has to add up. So if I take that 0.78 minus 0.22, I end up getting 0.56. This one, if I go 1 minus 0.78, I get 0.22. If I take 1 minus 0.36, I end up getting 0.64. And doesn't matter how I want to do this, but I'm going to do this next one first. So 0.22 or 0.36 minus 0.22 gives me 0.14. And then finally, 0.22 minus 0.14 is 0.08. Now let's look at that 0.08 real quickly. That point test is no blood and no breath. Guess what? That's what we had here. That's neither. They're not given either one. So this one is the probability of a blood test. This is the probability of a breath test. This is the probability of both. Neither is right there. And this plus this must equal this. This plus this must equal this. This plus this must equal that. Going this way, this plus this equals this. This plus this equals this. This plus this equals that. All the rows have to add up and all the columns have to add up. And if you think about this, this is the probability of giving a blood test, but no breath test. Well, look, it matches. This is the probability of giving a breath test, but no blood test. Well, look, breath test, no blood test. It matches. So basically, the table sorts it out exactly with the same information, just a little slightly different format than the Venn diagram. Appreciate you watching and look forward to seeing you on the next one. Thank you.